The figure shows a sketch of part of a curve with this equation. So that is this part here. And then we've got a couple of tangents. One when x is equal to 0 and one when x is equal to whatever that value is there. And in part A, actually, we're being asked to show that it's 4. So for A, I'm going to sub in 4 when x equals 4, y will equal 32 minus 4 to the 5 over 2. And we can put it in our calculator. It's just going to be 32 minus 32. But make sure you could do this without your calculator. It would be 4 to the half, all to the 5, which is 2 to the 5, which is then 32. So when x is equal to 4, y is equal to 0. And therefore A is going to be 4, 0. Okay, that's verified it enough. So we don't need to, by the way, you don't need to solve this equal to 0 or anything. You know, it's not like one of those situations when it says verify, you can just sub it in. L1 is a tangent to the curve at A. We're asked to use calculus to show that an equation is given by this. Okay, let's do it. So first up, I'm going to find dy by dx. I'm going to find the gradient function because the tangent has the same gradient as the curve at x equals 4. That will give me 8 minus 5 over 2 x to the 3 over 2. And then when x equals 4, dy by dx is going to equal 8 minus 5 over 2 multiplied by 8. That ends up giving us 8 minus 20, which is minus 12. So I now have the gradient and I've got this point. So that's enough to get the tangent. L1, we can do y minus y1 is equal to mx minus x1, or if you prefer, use y equals mx plus c. Y minus 0 is going to be minus 12 x minus 4. So y is minus 12x plus 48. And therefore, 12x plus y is 48. Okay, so that's these two bits sorted. We're then told that L2 has equation y equals 8x. They've done that bit for us. So y equals 8x is this green part. And then yeah, this purple part is what we just found there. 12x plus y equals 48, or y equals minus 12x plus 48. Now for C, we're told that the region R shown shaded in the figure is bounded by the curve, the line L1 and the line L2. We're asked to use algebraic integration to find the exact area of R. So what we can do is find the area of the triangle, which I'm going to call A1, and then subtract the area underneath the curve, which I'm going to call A2. So first for the triangle, well, the base is going to be 4, because remember we had the x value of A was 4. Just need to work out the perpendicular height. But this can be done by solving the two tangents simultaneously. We had y equals 8x for L2 and 12x plus y equals 48. We showed that for L1. Therefore, I can just sub in 8x for y here. I'm going to get 20x equals 48, and therefore x is going to be 2.4. Now that is the value at x at which they meet. I actually want the value of y. So then I would times through by 8, and it gives 19.2. So that is our perpendicular height here. This means A1 is a half times 4 times 19.2, we just end up doubling 19.2, gives us 38.4. Now for A2, this is going to be the integral from 0 to 4 of our function we had at the start. So that was 8x minus x to the 5 over 2. I will get 4x squared when I raise the power by 1, divide by 2. And then over here, I'm going to raise the power by 1 to get 7 over 2. Divide by 7 over 2, same as times in by 2 over 7. Evaluated between 0 and 4. Substitute 4 in, I'm going to get 64 minus 2 over 7 times, and you can just put this in your calculator, or you could square root the 4 to give 2, raise it to the power of 7. You end up getting 128. And then bringing this together, use a calculator, we get 192.7. And we're there. So that means the shaded area is going to be the area of the triangle minus the 192 over 7, the area under the curve. And this gives 384 over 35. Don't write that as a decimal. It would be a recurring decimal. If you round it, it wouldn't be exact. Okay, and I think, if I just remember correctly, they asked us for the exact area. So yeah, definitely leave it as a fraction. Okay, nice question then. So we've verified a point, we've found a tangent using differentiation, and then we very carefully found this area here. Well done.